and stochastic processes. The first video question was question 7. The question states that we are given z of t, which is eta 1 times cos omega ct plus theta plus eta 2 times sin omega ct plus theta, where theta is uniformly distributed in 0 to 2 pi. Eta 1 and eta 2 are WSS, which is wide sense stationary, and all eta 1, eta 2 and theta are independent. So we are asked to the first part asks us to find expected value of z of t. So for expected value of z of t, we will first find expected value of n1 of t, which we can write it as eta 1, which is equal, and similarly expected value of n2 of t is eta 2. To find expected value of z, we can write it as expected value of eta 1 cos omega ct plus theta plus eta 2 times sin omega ct plus theta. Now we can split them, since n1 and n2 and even theta are independent. We can split them into two separate individual expected values, which is expected value of eta 1t cos omega ct plus theta plus expected value of eta 2 sin omega ct plus theta. Further, we can also split n1 eta 1 and cos theta term again, which further dissolves this into two expected values. First one is expected value of eta 1 into expected value of cos omega ct plus theta plus expected value of eta 2 into expected value of sin of omega ct plus theta. So now using expected value of function as x fx of x dx, which is basically eta 1 by 2 pi 0 to 2 pi cos omega ct plus theta into d theta, and over 0 to 2 pi, and another term will be eta 2 upon 2 pi 0 to 2 pi sin omega ct plus theta d theta. Upon solving these terms cancel out and the result is 0, which gives us the result of first part, expected value of z of t as 0. The second part asks us to find r, z, t1 and t2, which is basically autocorrelation, and it also asks us whether z of t is a WSS or not. But WSS is wide sense stationary. So we'll start with finding R2 of T1, T2, which is basically expected value of z of T1, z of T2. Again, substituting z of T1 from the value given above as eta 1 cos omega ct plus theta plus eta 2 sin omega ct plus theta. Doing the same for z of T2, just replacing T1 with T2 in the second part. Now we just multiply all the terms, which basically gives us 4 expected value terms as eta 1 cos omega ct into n2 t2 cos omega 2 omega c t2 plus theta. Second term is expected value of eta 1 cos omega ct plus theta, n2 of t2 sin omega ct plus theta. Third term is expected value of eta t1 sin omega ct plus eta 2 into eta 1 cos omega ct2 plus theta. The last term is expected value of eta 2 of t1 sin omega ct plus theta into eta 2 of t2 sin omega ct t2 plus theta. So finally we can again take the eta 1 and n1 t1 and then all the eta terms outside with and making them in terms of r. So we get r of n1 of z, expected value of cos omega ct1 plus theta into cos omega ct2 plus theta. Next term is the same thing with eta 1 eta 2 outside, another eta 1 eta 2 outside, and the final term will be r into z, expected value of sin omega ct1 plus theta and sin omega ct2 plus theta. Now expanding the expected value term as in the form of integrals, we get 1 by 2 pi 0 to 2 pi cos omega ct2 plus t1 plus t2 plus 2 theta d theta plus theta omega c z. Doing this for all the 4 terms, in the end we get the we get z of r2 of t1 and t2 as half of rnz plus rnz into cos omega c z, which is basically r of z, which implies that our z of t is wss, that is White's and stationary. Moving on to the third part. The third part basically asks us to find rz of 0 if z of t is White's and stationary. So just substituting the values in the equation in part 2, where we substitute z as 0, so rn of 0 plus r2 of 0 into cos 0, which is 1. So half of that is half of expected value of eta1 square plus expected value of eta2 square. So this ends the 7th question.